Hello and welcome to the Dinosaw number 217, another 7 curious, interesting things I saw last week. So as ever, let's crack on. First one is Twist. This is whole body teleoperation. I said teleportation. It's not that. This is teleoperation. So a person in a mocap suit which is controlling a robot. So it's doing it in real time, although this is sped up footage. This is, I think, 4 times sped up. But this is from Stanford and Simon Fraser universities. Didn't even know there was such a thing. Got a friend called Simon Fraser. Hello, Simon, if you're watching. However, this is really interesting because it can then obviously create movements in the robot by a person doing it. So where's this going? So you're thinking if you're an actor of the future, then you go into a mocap lab, or you really just use AI to do that now. And you can then have your body movement scanned and therefore can be replicated on stage or on a movie or a play, for instance. Likewise, if you can manage to mocap a athlete, for instance, you can replay them in real time. Maybe there's a goalie that you really need to get a goal past, then you can actually recreate them as a robot. So I really like that, where that's going. Obviously, I've made all that up, but it seems plausible. This is Lego GPT. This is from Carnegie Mellon, and they have a text to Lego generator. You can play with the demo online. It doesn't do the swanky 3D thing though, but I did try it. I asked it for an F1 car and it just made this sort of lumpy thing. So it's not brilliant, but if you want a basic model, it will do a fairly good job at that. So what's interesting about this one is that it actually creates what they call physically stable Lego bricks. So it creates things that actually won't fall apart. So it won't create sort of blocks hovering in the air between 2 other blocks, for instance. So if you're looking for inspiration about what to do with your Lego blocks, then head over to the link down below and have a play. The source code's there, but also there's a demo you can play with. The 2028 LA Olympics has an air taxi sponsor. Of course it does, an official partner, should I say. And this is Archer Aviation. And this actual video is from their transition test, which is where it goes from vertical to horizontal flight, which is a pretty big milestone. However, more details. So there will be several places where this will take off and land. Can take up to 4 people, I think up to 20 minutes. They say between 10 and 20 minutes. LAX will have one of these vertipads, as vertiports, as they're called. So you can probably get off your airplane and then you can go to your venue of choice. It doesn't say who's allowed to be in them, whether it's for journalists, VIP, or even athletes, imagine that. However, this is the Archer Aviation thingy. It has 12 rotors, it's electric, and is kind of cool. So there you go, interesting, who'd have thunk. This is Tesla's Optimus bot doing a dance. So there's lots of tests that robotics companies are doing. It used to be somersaulting, then it was running, and now it seems to be dancing. It seems to have all the sort of the balance and the fluidity and the speed and the natural movements that they're looking for right now. So this is Tesla's new version of it. Obviously, if you remember 2021, there was that really cringy thing on the right hand side, which was clearly a bloke in a suit. But I think really just to save face, really, they've gone all the way 4 years later and they've showed you their actual dancing one real time. So I do implore you to have a look at the actual video if you can. Try and search for it on YouTube in case you don't want to go to X, but the link is down below. It's better with the music, that's all I'll say. There you go. Interesting, dancing robots all over the place. This is neuromorphic vision via spiking neural networks. Now I'm going to try and do this justice because it is really interesting, but also quite tricky to explain. It is essentially a chip that has a built-in neural network that can recognize light, can understand what's going on in the light, and then store the result, all on the chip without any external processing. So what that really means is there is essentially, it's looking out for a certain type of movement, in which case, you know, as an example, you've got a hand which is waving from left to right. Any positive movement in one direction is a blue pixel, anything red in the opposite direction is a red pixel. And therefore what it's looking for over time is this sort of displacement of these pixels. If it recognizes that, it says, I found what I was looking for, I found a wave. So in visual data, it can automatically find what it's looking for. Now, why would this be interesting? Well, it'd be interesting in things like self-driving cars, which may, for instance, be looking out for some sort of danger. If they spot the danger instantly, instantly it will then say, I've been looking for this, I found it. It doesn't have to process it, it's instantly there. Now, they've tried this with, I think, infrared or ultraviolet, one of the two, and this actually is now working with a single pixel using visual should you say, like natural light, like humans can see. So yeah, where you can go with that, I'm not really sure, but that's really interesting. Imagine chips that automatically can see something instantly that they've been looking for. Interesting. I think I explained that. This is actually a guy from Tory, and this is the Open Muscle project, which I thought was really interesting. So there's a new demo or a new project you can download. So there is a circuit board, for instance, and the code you can actually get as well, and you can build your own version of this, 3D printed, etc., etc. Now, it started out with just sensing muscles on the forearm and then turning that into some sort of data, which is what you're seeing right on the screen right now, and then created this project where you can actually then use this little, well, actually it was apparently a hand grip strengthener for guitarists, but really sort of was the genesis of this, which you can now use to then control a hand. Here you go. There you go. That's Tori showing you how it works. There you go. So if you want to make one of those, which I think is amazing, then you can download it. But also, if you didn't know that the Open Muscle project exists, well, now you do, and that's pretty cool. And finally, we have the Internet Road Trip. This is I just love things like this. Neil.fun is always a fun place to go and look at the latest experiments. And this is the latest one. So head over to the URL. And all it is it chooses a place on Google Earth or Google Maps, and you can look at it in Street View. And then everybody votes whether you go forwards, left, right, or for instance, you blow the horn, for instance. So there you go. That's all you do. And it literally, this is real time. This is me capturing it from the screen. And it really is this slow. So everybody votes, it then figures out what you've all voted for, and then it does the thing in Google Street. So as a for instance, if you went from Vegas to Maine, it would take about 10 months in this way. So patience is important. I just love these kind of daft things on the internet. There you go. Hopefully that was interesting. Hopefully it was useful. If it was, give it a like, share it with somebody, and I will see you next week.